Hello,
Hi there. How are you?
I'm good. Just getting ready to start training you, the first person to join.
Nice. I'm the one who just listens with the hole in my head, but yeah, just want to follow along the best I can.
That's cool. That's good. So, today we're going to talk about some interesting new features and I'm going to show off some new skills a little bit and hopefully get to play with the manifest, the scaffold manifest for the customizable scaffolds, which we delivered last night.
Yeah.
And yeah, so that's going to be fun. I'm currently fixing a few bugs in that manifest. It was doing some things out of order and not copying all the files right.
Hmm.
So I fixed that up. Should be almost fixed here.
Love
So
it.
I'm going to show off some interesting processes, hopefully. Um, Let me find. Oh, hello, team. Hi, Jonathan. Um, I don't think Jonathan has met Ian or Andrew yet. Have you?
I have not.
All
Hey,
right.
Jonathan. Nice to meet you. How are you? I might be jumping in and out. I'm just trying to listen in between fire
Nice.
drills. So,
Nice.
Sounds
Um,
good. Nice to meet you guys.
yeah, Jonathan is an acqui-hire. We're buying um, his product and bringing him on the team.
oh,
Um,
congratulations.
yeah, he made a
Thank
product
you.
called PageSpace, and we're gonna incorporate that as part of the Parallel Drive product offerings. And his full-time job is basically to keep building page space.
Love it. That's
Yeah.
great. Congratulations. That's so cool for you guys.
Yeah.
Appreciate it. Yeah, it's exciting.
Amazing.
Good
Jonathan.
good to
Nice to
see
meet
you,
you.
Ian. How you doing?
I'm doing well. Sorry, I thought this training was starting an hour later today.
It
Did that change?
was, and then it changed again. So
Okay. Okay, no,
just a
that's
little
fine. I was just
scheduling
making sure I didn't
confusion.
change it by accident earlier, so we're all good.
No, it was a little scheduling confusion because we started a new series of meetings with the Wolf Games team on 3 p.m. every day, except we already had these meetings set up for 3 p.m. Tuesdays. So he moved that to 4 p.m. to accommodate after I'd already said, hey, we're going to meet at 4 instead. So, yeah, it was just a little confusion.
Okay, all good.
Yeah, sorry about that. Um, okay, so a lot has changed in the last 24 hours. So let me try to catch you guys up a little bit. I'm going to share my screen. I'm going to turn off Slack so I don't get interrupted by it. And maybe, yeah, I think I'm good. All right. Yeah, I think I'm good. So I'm going to share my screen and we're going to dive in and explore some new features real quick. So, oh, here, share. If I share this window here, yeah. So you can see I've got kind of an agent running. I'm using cursor web agents a lot lately, mainly because they make it really, really easy to just fork a bunch of sub agents that will work in parallel. You can fork up to four at a time, which I'm finding actually works quite well because there's usually some things where there's dependency chains where something has to happen before something else happens. So you can get four agents working at a time in parallel, knocking out like the dependencies, and then another wave comes and builds on top of those dependencies and so on. Um, I find that's pretty nice workflow. But if you look back at what it's been doing, so it's diffing the change files, and then it runs a churn hotspot analysis on that. Um, and let's see. So this does its code review, and it runs from AIDD churn. It finds the scaffold create test um, has 477 lines of code, which is a little bit too much. It's a little hot, right? And then create E to E test has 372. So it's looking at lines of code. It's also looking at how much the file has been touched, like how many times that file has been committed in the last 90 days. And it uses that as an indicator of churn, which can indicate that maybe there's a lot of bugs and bug fixes happening in that file. And maybe it should be a target for refactoring. So it also looks at cyclomatic complexity. Um, so if I ask it to just like give us a breakdown on, here we go. If we ask it to give us a breakdown on that churn command, actually, let me just run it. AIDD churn, so you can see the output. So that what we just did was we ran a code review, and it included that churn as part of the code review. And it found a few things. It looks like mostly minor things, a couple of moderate issues. AIDD dev artifacts copied into user projects. So bin index.md.
Eric, can I ask a question, or I don't, maybe it's not the right time, but have you
Yeah.
seen Anthropic with Claude's new code review tool that they released? Have you checked that out at all?
Yeah.
And
So the thing about that is it costs like $25 per run, which
right,
is a little on the
yeah.
pricey side.
Hmm.
I haven't actually done an A/B comparison between their code review and our code review, but I'm betting they're not that different in terms of quality,
Got it.
and they cost significantly more.
Yep.
So I'm not sure of the value. I need to test it out more and figure it out. But Ian, you want to?
Yeah,
Okay,
I'd be
cool.
curious to know how it's better, if at all, because I feel like the code reviews themselves are usually really, really valuable, except in the cases where AI can't catch its own slop, which would be helpful for like, a memory file of some kind. So maybe they incorporate that. But for example, in like the RightWay PRs we've been working on, Jan will consistently have to leave the same PR review feedback, or I'll have to keep referencing that in different reviews because the AI can't catch that. So that seems like the real value that would be, improved upon in a AI review.
Yeah,
It's like catching its own slop that it keeps doing over and over again in different PRs or different, use cases.
yeah, and no matter how much what you're paying for with that $25 is just a lot of thinking, a lot of tokens. It's just talking to itself a lot for that $25. And what I've found is that sometimes the more that it talks to itself, the more it digs its heels in about making the same mistakes. So, for instance, we have a security rules in the AIDD framework that help it understand how to do proper um, token comparisons because the kind of long preached standard for token comparisons is to do a timing safe compare, which was a standard that arose more than a decade ago. The problem is timing safe compares have never been timing safe because compilers optimize the timing safety away. Really smart compilers figure out that the tokens are going to come out the same and compare while it's comparing and short circuit, which causes it to leak timing information that helps the attacker play hangman, right? With your like if you can play hangman with the token, then it's basically like putting a little plastic chain on the door and calling it locked, right? You can just bust it down, keep going, right? Use a little brute force attack and break in. So no matter how much the AI agents think about that, they still mess it up and they still don't catch that security flaw. So I had to be really, really explicit about how to do it right and why to do it right. And even then, an AI agent will still come along and make a secure version insecure by replacing that hash compare with a unsafe timing safe token compare. And so we literally have to leave code comments in there saying, don't do that,
Right.
right? To keep them from doing it. Yeah, Ian.
So, building on that, and this can be saved for a later time, I just wanted to note it. Do you have any ideas of how to mitigate that going forward? Like, obviously, during PR reviews, if it keeps coming up, the team, we could just work it into a rule, right? But maybe it'd be helpful to have some sort of log of like how often the same thing gets like said or requested for review, at least on per team basis to,
Yeah.
work that back in the right place, right? So just wanted
Yeah.
to throw that out there.
So what's going to happen is we're going to have a service that'll keep track of what's going on with our AIDD fixes and reviews and things like that. And we'll set up the same kind of service for Wolf Games as well and some of our other clients so that so it basically just keeps track of a telemetry of mistakes that the AI is making and mitigations for those mistakes. And then so Claude Code has a built-in insights command that you can run periodically and get some good feedback about like how to improve your project using rules and um, you know, adding constraints to your agent skills and things like that. I don't know if it makes specific advice about exactly how to mitigate it, but it raises the issues for you. And we can do the same thing and then convert those to task epics and then have the AI automatically fix the issues. So the AI trains itself as you continue to use it. So the more you use it, the better it gets just automatically in this perpetual positive feedback cycle.
Cool. Thanks.
So, and the sooner that we get that up and running, the further ahead we'll get in front of everybody else. So we're going to get our feedback cycle running as soon as we can. And maybe I can get you and I would think probably Jonathan and you should probably pair up on doing that and implementing that. Um, but one thing to keep a handle on is we probably want to store those as logs and we need to semantically index them along several different index clusters. So and I'll we can get into like the efficiency of the RAG strategies and stuff like that later. Thank William.
William, yeah, it's me. Yeah, yeah. So we discussed that we're gonna enforce some architecture rule from Wolf Games, right? So,
Mhm.
so I wanted that if this review we're taking this into considerations, like gonna check all the files, we're gonna all the code base that see if the architecture is follow our rules.
Yeah. And William, just so for your information, these trainings are public. They're recorded and put on
Oh, it
GitHub.
is. Sorry.
So
Oh,
probably
I thought it was just for us. I'm
no, no,
sorry.
no. So probably just keep that in mind during the training sessions every Tuesday. These are broadcast live and they're public and recorded on YouTube. So just keep that in mind and just like don't you probably don't want to go into trade secrets, but
Got
yeah.
it. Got it. Got it.
And
I just
William,
wanted to make sure you're aware of that.
you should probably take the API keys out of the chat that you just added. So I'm just kidding. I'm just kidding.
I'm like, what API? Yeah. Yeah, just keep that in mind. But yeah, we're definitely sorry, was there a question in there?
No, no, it's all good.
Okay,
I
okay.
will check in with you later.
All right, no problem, no problem. Yeah. So, where was I? I got a little distracted. Oh, yeah. We were doing not the review. I was showing the new command, right? The refactor target command. So this is the hotspot analysis. So the AIDD churn command is a new hotspot analysis tool, and it uses a 90-day window to discover churn, which is like how many times you've committed to the same file. Um, it also looks at some other factors. We're going to go into this a little bit. You can see The bin AIDD one is the number one. The dominant signals churn 7 commits in 90 days. This is really basically just because I've been adding new commands to it, so it's not really a bug fix churn issue. But it also has a cyclomatic complexity of 15, which is about 6 higher than what I like to see, um, and a density of 36, which is a little bit lower than I like to see. Um, so cyclomatic complexity is the number of independent code paths through a function. And the higher that is, the more you get like, um, the more difficult it is to test because you get this combinatorial explosion of paths through the code base, and like how to test those becomes harder, right? Um, so we want to minimize the cyclomatic complexity. And one way you can do that is instead of using a bunch of if and else statements, especially nested if and else statements, you can create command dispatches, basically where there's one little switch and it's keyed, and then there's one path through the code base, and you just pick it, the right key, and it runs the right code, right? But so it kind of it reduces the opportunity for crazy out of control like if else branching and stuff like that. So that's one thing, the cyclomatic complexity. And then once you've got that down, like if you've set up a function per path and then you just test that path and there aren't like 6 different ways to get into it, right? Then it's an easy unit test to see, does this path work? Does that path work, etc. Instead of having this weird combinatorial nested like conditions to get into it, right? So that helps a lot, reducing the cyclomatic complexity. Um, let's see, what else? The density. The density is a measure of information density. So basically, we use information theory, and we basically just run gzip on it, and then we compare the gzip size to the uncompressed size. And the idea is the more that it can compress, the more repetition is in the file. So it's maybe an indicator that there's some copy and paste going on, or some opportunity to refactor, like some boilerplate code to use callable functions and things like that to improve the code quality, reduce the potential number of bugs. Because if each of those things, if each one of those little boilerplate instances contains a bug, and there's 15 instances in the file, right? That's 15 bugs instead of one bug, right? So it's an opportunity. It just kind of points out opportunities for abstractions and like hiding complexity behind a single function, right? So this thing kind of audits using those very deterministic metrics. The other metric is just how many lines of code is it, right? You want to keep the code clutter down for the same reason you want to keep clutter down in your house, right? More clutter equals more surface area for bugs equals more bugs, right? More places for bugs to hide. So yeah, we want to keep those things low. Also, having files that are too large tends to produce um, slower merges and more churn during the merge process because there's more opportunity to conflict with other developers working on the same file. And there's also more opportunity to introduce things like shared mutable state that could cause like timing dependency bugs and things like that. So it really helps to reduce that. We keep the codes, the lines of code down per file. Another thing that is important to understand about that particular metric is that the more lines of code in a file, the more you overwhelm the AI's context, and overwhelmed context dilutes the model's attention, right? Because models have sparse attention, which means they can't pay full attention to everything in their context window. So in order to keep better attention on the things that are important, you reduce the amount of context in the context window that would distract them from the things that are important, right? So a lower number of lines of code as it's reviewing that particular file or making changes to that particular file is going to help it perform better and make better decisions on that file. So this new command it doesn't actually pollute the context of the AI because this command is implemented using deterministic tools, a command line tool that is deterministic written in JavaScript. The AI doesn't see the process of running that analysis. All it sees is the output of the analysis, and then it can make intelligent inferences based on that output and give you advice about how to refactor it. So that's what you're seeing here is it's pointing out the hotspots and giving us particular advice about what to do about it. In this case, our CLI core has high cyclomatic complexity. And in this case, it's tied for the highest in the code base and a low density, which means there may be some structural repetition that we can exploit, turn into callable functions and so on. So it gives us specific refactor targets and also some good ideas about how should we refactor those. So gives us lots of really great information. And this helps us fight the kind of code slop that you get from AI. And I made this for a couple of reasons. Number one, as I was trying to merge a 6,000 code line, change, one of the things that I wanted to do was really reduce the bloat. I wanted to identify which files are responsible for these 6,000 lines of code, and is there opportunity to reduce the clutter here and have less to review in total, right? So that was number one. I wanted to cut this down and whittle it down and figure out refactor targets and figure out how to merge it more cleanly. Another thing that kept happening was, I'm editing these core libraries for the AIDD command and our generators and stuff like that. And I'm looking at the scaffolding tools and stuff like that. These are all part of the scaffold resolver and scaffold resolver test and scaffold commands. These all go into the AIDD command, which is our central CLI that just dispatches and runs these different things. And in the initial version, it bloated that way too much. It put the implementation of that module right inside the great big AIDD command itself, rather than as submodules that get imported into it. Right. So I wanted a tool to identify things like that and point them out for the AI automatically, so I wouldn't have to do a manual code review and see the slop and have to remind it, hey, it's probably time to break this, 600 line file down into smaller chunks so you can handle it better, right? I don't want to do that manually. And, a human in the loop shouldn't have to do that stuff because these are things that we can analyze deterministically and figure out. So, yeah. So now it's giving us high priority targets, tells us exactly what's wrong with them and gives us a good idea of what to do with it. So that's number one. The other thing that I added was the AIDD fix command, which I just used to fix some bugs, but maybe we can find another bug to fix. Because I just did a code review back here. All right. Okay. So here's our code review. Got some positive comments here. npm init -y versus scaffold package JSON convention for named file scaffolds that include their own package.json. Scaffolds package JSON is copied first and is silently overwritten by npm init-y. Scaffold authors package.json has type module. So we need to find out if this npm init-y is always run or only run for manifests that include it. So I'm going to ask it about this. But also, yeah, we probably don't want to run the npm init-y for those. And we should probably point that out in the documentation as well. So I'm going to ask it a question, right? Is npm init-y always run, or is it only in a select number of manifest scaffold manifest files. If it's always run, that's a bug that we need to fix, and I can show off the fix command. That's what I'm trying to get at. It's like, is there a bug that I can point this at? Check the scaffold manifest files. So, okay. If it's only run by the scaffold manifest YML, it's not a bug in the scaffold runner, but a bug in the manifest, but only if the manifest already includes package.json. Maybe we could, well, yeah, maybe we could remove any mention of npm init-y from our documentation because it's probably an anti-pattern. Okay, let's see. What does it say here? Not a framework behavior. It's only a step in the scaffold examples manifest. Next, shadcn doesn't use it at all. It's an scaffold authoring concern, not a framework bug. Okay, so it invented that npm init-y in that manifest. So I'm just going to say probably an anti-pattern, and we should not include it in examples. So now we can do AIDD-fix, and it'll run through the process. In this case, this is not a very complicated bug to fix. It's just basically a documentation only thing. But it can kick that off. All right. So in the meantime, Ian, I think you were saying that you were able to land the new changes in RightWay. Is that right?
Yeah, those have been merged into me earlier today.
Okay. So the next version of RightWay is going to include basically the ability to unit test AI prompts. And you might be wondering how that works because AI prompts are non-deterministic. The AI models, language models, are non-deterministic by nature. They include randomness in them. So there's no way to say something that's going to pass every time or something's going to fail every time. And it's really just statistical. You got to run it more than once, right? So I believe by default, we run each test 4 times. Is that right, Ian?
Yep, that's correct.
Each one with its own subagent and its own context, so it doesn't get polluted by other runs and other test assertions, right? So that allows us to create this collect statistical analysis of our AI prompts. But we also don't just get a pass or a fail out of those unit tests. We also get a response score. And the response score is generated by a judge agent. Is that right? Ian, just chime in and correct me if I say anything wrong here.
No, you're right. I also posted a link to the updated README that summarizes how the tool works, and it has most of that information in there. But yes, you're correct. There's one agent that takes in the prompt under test and the user prompt, creates output from that, and then there's a judge agent that judges the output and gives a score based on how closely it determines it matches the user prompt based on the prompt under test. So
Yeah. So this is going to be a tremendously useful feature for anybody shipping AI products that contain AI features, which hopefully is just about most new software is probably going to need to ship some AI products to keep pace with everybody else, whatever everybody else is doing, just because agent workflows are so powerful that traditional, point and click software is starting to feel a little bit dated. And, for AI power users like us, right? Clicking around on some web form somewhere feels a little clunky when we can just talk to the computer and tell it what we want. So yeah, um, it's for some reason writing unit tests for documentation over here. Is it? Scaffold, not a bug in the scaffold runner. Minimal fast running scaffold. Uses E to E test fixture. Okay. Given the scaffold run, should produce a project with pre-configured package.json. Oh, there we go. Not npm init-y. That's nice. Given the scaffold run, should produce package.json with type module. So the project is an ES5 module or ES module by default. That's good. So that's good. These are good requirements. I'm happy with that. Init-y is not a step in the manifest, should not overwrite the template package.json with generated results. Cool. All right. So writing a failing test, given scaffold example, create, set type module and package. So that's just setting it to make sure that it's doing the right thing here. That's a good test. That's fine. Okay. The more direct approach. All right. It's fine. It's working. All right. Sorry about that. Where was I? I was talking about the RightWay, right?
Yeah.
So anyway, projects that are using that can start to record their prompt scores over time. You can actually graph it over time and have an average score and add that to a dashboard, collecting metrics automatically. We don't have the metrics gathering parts written yet, but those will come. And as they come, and we'll be able to monitor the health of the prompts and also detect model drift in production. So in other words, we'll be able to run our tests in production periodically, probably once a week or once a month is probably enough. But just run your prompt tests in production now and then, or in the production environment now and then. It doesn't have to be production itself, but a production like environment, right? And you can detect model drift. And so model drift is when the company releases a new model and uses the same like shortcut name as the previous model that you were using, and and you can detect like sometimes the new model will be like um, it'll be basically the same model but maybe downsized a bit and sped up, but in the process of downsize and speeding up they sometimes basically bit crush the nodes in the neural network. So they use like int4, they'll sometimes crush them down to int4 when they were before during training, they were like 16 or 32-bit floats. So it radically reduces the capacity of the AI model. And sometimes that affects their capabilities and sometimes has an adverse effect on their capabilities and it makes them fail at stuff that they used to be good at. So you can detect that by running these tests. Um, and you can also detect what small changes in your prompt wording can do for your response scores. And you can see, like, if your scores take a dive after you release something new, maybe you updated the wording of something or you inserted something and you can see how it affected the capabilities of that prompt over time. So that's going to be extremely valuable. Um, let's see, are there any other new features of the AIDD framework or RightWay that I need to point out? Because we had like major release. Oh, yeah. So there's a whole new set of skills that I should probably review real quickly. We don't have time to go in depth on them all, but Here, let me move this Zoom stuff out of the way so I can see what I'm doing. And bring up chat. There we go. There's in the chat, there's a URL for the RightWay stuff, RightWay documentation. All right. So, where was I going? Remind me. My brain's not keeping track of what I'm doing. My attention is diluted.
We're going to go over some new
Yeah,
features.
the new features. So, GitHub AIDD. In here, we've got a bunch of new features under AI skills. So we have the churn feature we just discussed, the fix feature that you just saw in practice. You could see it wrote a failing test and made sure that the test passed and ran reviews and stuff. That's all built into the AIDD fix command. But there's a bunch of new stuff like AIDD ECS and AIDD observe. These are important ones. AIDD service and structure. These all tell it how to use our central dispatch mechanism, which is going to be super important because our central dispatch mechanism basically gives the AI the ability to control anything that a user can control. So if you've heard of the Model Context Protocol, MCP, it's basically like giving the AI an MCP for your app, except your entire app functionality is built on top of it. So the MCP is not like this separate step that you slap on top to teach an AI how to navigate your system. It's literally how you, as a user, navigate your system. And the AI just plugs right into the same APIs that you plug into as a user. That means the AI can do anything that you can do. With some restrictions, you can set restrictions and say, hey, the AI shouldn't be doing this or shouldn't be doing that, right? You just don't expose that to the Jiron API. The Jiron is a competitor to the Model Context Protocol, MCP. And you can find that at parallel drive /Jiron. The specification is here. And it looks like this. So you can see it's not a JSON-based format. And the reason that it's not a JSON-based format is we can fit a lot more information into the same number of tokens. So it's a lot more compact and faster. It doesn't clog the agent's attention. It doesn't dilute the agent's attention as much as JSON does. So we try to do as much as we can. And when we're building APIs for agents, we use Jiron instead of JSON. And we use Jiron instead of MCPs for this reason. Jiron also has the major advantage of being progressive disclosure based, which is basically how the web works, right? You don't have to have a complete index of the entire web in your brain to understand how to use the web. You go to the website you're interested in and you see the menu options on that website. And now you know what you can do with that website, right? You discover as you explore. And that's the same process that Jiron uses and the same process that our agents use. It explores things as it needs them instead of trying to jam everything into its context all at once. And this is important because like if you get a bunch of like MCP servers installed in your workspace, you could clog most of your useful attention just with MCPs and just with basically the definitions of tools that the AI can use. And that's bad because then it has less attention to focus on the problems that you are trying to solve with your agents. Jiron works with progressive disclosure, so it sees just what it needs as it's working instead of everything. Instead of stuffing everything down its throat at once and expecting it to just swallow it all, right? We let it digest in small bite-sized pieces. And that just makes it perform a lot better. But this reduced token count also makes it faster and cheaper. All right. So you get lower latency responses and less expensive overall for the tooling and API use. It's going to cost less. So yeah, that's Jiron. and we have the ECS skill. And ECS is Entity Component System, and is made popular by video games. And basically, the idea is that it's a data-driven data state model that keeps track of the application state or the game state in the case of video games where ECSs were really popularized. And so we have this ECS system that was designed by Chris and I for Adobe. And we used it as the main engine of application state for Adobe Firefly. And it worked really, really well. We had a previous ECS implemented in other projects that most of Adobe was using this other framework that we specifically decided not to use because we wanted, video game real-time kind of performance in Firefly so that we could handle like the real-time stuff that's coming, the real-time productivity features that are coming in future Gen AI solutions, right? And by the way, if you haven't seen those, they're pretty cool, right? There's Google has like a game engine. Basically, it's a real-time Gen AI game engine. It just like generates everything in real time as you're playing the game. So that's kind of where the future is going in the video game industry, and that's where we wanted to be in the creative asset production realm. We wanted real-time rendering and real-time interaction, so you could basically fly around a scene as if you're playing a video game. So we wanted a data engine that was capable of that kind of real-time responsiveness. So we built one, and it's 1,000 times, more than 1,000 times faster than the ECS that was built into Adobe's other products. So it's very, very performant. It's ready for, AAA video game kinds of performance, very low latency Twitch kinds of interactivity. It can do all that stuff. So we've got that, and we can use this as the engine for all of our application state across every project that we produce. And this automatically can plug into Jiron. In other words, we can produce our Jiron APIs from our data model automatically. So we don't have to do any extra steps to hook up steering, AI steering of applications, which is great. If you want to build a video game, you can have the AI build an engine and have it build in a level editor, and then have it just drive the level editor to build out the levels. And then you get this self-consistency across the game generation or, things like that. Same thing with applications. You can have it build the basic application mechanics and then build editors and, build interaction points in the application that use those mechanics and your component system and your services, and they're all backed by the same thing. Another major advantage to this creates a central dispatch mechanism, which means that every user interaction invokes a command, and that command is automatically dispatched to a central system where we can insert all kinds of observability, telemetry, collect all kinds of information about how the application is being used. So we can automatically hook up our analytics, our logging, our, keep track of full telemetry of every user session if we wanted to, right? Now, that means that we probably need to be careful about how we're logging that telemetry, right? We don't want to be storing people's personal information and stuff like that. But that gets a lot easier too, because everything is filtered through the same system. That means we can use the same kinds of heuristics and scans to identify personally identifiable information and filter it out of the logging. So when we have one central access point for logging, you can just plug everything through that one point. So that gives you, it reduces the opportunity for bugs or leaks, data leaks, to pop up all over the system. If you were not using something like this and you were kind of handling everything ad hoc in the place where it's used, then you would need to go to, if you found you were leaking user data, you would need to search every spot in the application where it's possible to do that kind of interaction and see if it's there. And, you're probably going to miss a few. Even if you use AI, you're probably going to miss some. So for example, I frequently search for common patterns with AI, and it frequently misses instances of those common patterns. So it'll raise like 6 or 10 or something like that and leave 2 more lingering in the code base that we have to go and fix later, right? When you're channeling everything through central dispatch, you've got one place, one single source of truth where you manage all your middleware. And that middleware can inspect everything that's flowing through there and also do things like dispatch other actions based on that, or filter the signal for processing downstream, things like that. So it's really powerful system, and one that we're really excited about implementing and starting to build applications using. So Ian, you might want to look at this because I know you're building some features for paralleldrive.com. It'll be cool to integrate this system in the paralleldrive.com application and start treating it like a proper application, right? With a proper application architecture, central dispatch systems, logging, all that kind of stuff. So it's going to be really, really cool. Another interesting thing about this is that because it allows the AI to drive the software just like a user can, you can also use it for user testing. So you can, even before you build out a UI for your application, you can test the user journeys and make sure that user needs are being satisfied by your app, which is pretty cool. Like if you're making a video game, you can play test a game mechanic even before you've implemented the graphics systems and things like that. And the AI can give you feedback about whether or not it was fun. So yeah, really, really interesting stuff here. There's all kinds of cool opportunities and things that you can build on, right? All right. Other skills. We have the observability. So this ECS, all the data points in the ECS become observables that you can subscribe to. And once those subscriptions are made, you can do things like update the UI and things like that, right? Then we have the services. Let's find out. Let's dig into this. Actually, let's look at index.md. I think that's just a brief description. Enforces asynchronous data service authoring best practices. So let's take a look. All right. Asynchronous data services live in the services layer per structure, adhere to the namespace for type and function organization. Data is read-only JSON values or blobs. So we've got front-end versus back-end services. We don't allow promise or async generator returns in the front-end. Back-end services are called by front-end services, right? And typically return promises or async generators. That's pretty cool. Yeah, constraints, UI components, unidirectional path, data down via void actions, data up by observables, right? Backend services are usually stateless. Functions typically return a promise of data or async generators with data not called directly by the UI. So services kind of plug in front of, if you have like a third-party API that you're calling or using, services kind of plug in front of that, right? And that kind of creates this abstraction point. So if you want to swap out your database backend, you can. And all you got to do is update your service definition to target the right database, your backend service, right? And so on. So this kind of creates this really good way to kind of plug into things in an agnostic, service agnostic, API agnostic way. So for instance, if you wanted to call a model, a Gen AI model, right? You could abstract which model you're calling behind the service and or even intelligently route to different models based on the messages that you're trying to, or based on the payloads that you're trying to process. So really cool. The service APIs implement best practices for building services and so on. Structure, let's see what this has. Here we go. Enforces source code structure and interdependency best practices. So when creating folders, moving files, adding imports, when the user asks about architecture, layering, or module dependencies, it looks at this. So we have our components, plugins, services, and types. And types only depend on types. All these things are driven by types, so they have type rules that help them understand what's available and how to use it. And I think that's all the time we've got, so I can't go into too much depth on this stuff. But yeah, so take a look at these new features. I think in particular, the new churn command is going to be super useful. And the ECS system, just learning how to use the ECS system and services and things like that is going to be very useful. Or you can just point your AI agent at them and make sure that they know that they should be using those skills, and they can automatically build that stuff out for you. So yeah, that's the new AIDD framework version release that just went out last night. And there's more coming. Lots more interesting stuff coming. We're going to merge in the new version of RightWay and get those the AI unit test system running and so on very soon. All right. So there's another version just around the corner. I'm going to patch the. Oh, I don't think I even went into detail in the on the scaffold generator yet, but you're going to be able to create your own custom scaffolds and your own custom configurations and your own custom skills and stuff like that in your scaffold, and then generate new applications from zero. So you'll be able to run a command line with a prompt and generate an application from that prompt, from that command line run from scratch. So you'll start with a blank directory and a scaffold to point at with your text stack preferences and stuff like that already set up. And then you can launch a new greenfield project in minutes instead of hours or days, including all kinds of things like authentication, authorization, dashboards, stuff like that. So you can create this really cool scaffolds with all the bells and whistles already done and get a real head start on new applications. So all the common stuff that you build into applications over time, like analytics and logging and dashboards and user accounts and all that kind of stuff, enterprise ready features, all that kind of stuff can be baked in from day one as soon as you start a new greenfield project. So, and the major advantage over previous template scaffold systems is that it's always using the current versions of everything, all the security updates. It pulls in the newest AIDD stuff dynamically at runtime and so on. And I have another meeting I've got to get to, so I got to bail. But thanks for joining. We'll talk to you guys later.
Thanks. Bye.
Thank you.